Hi everyone, for this exercise we are going to be working through the second part of Appendix A9 from the Francis and Garing book, and we are going to be producing a Pearson's correlation coefficient, or a Pearson's R, and then we are going to do a linear regression. So in this data we have two variables. We have years of experience and we have weekly salary measured weekly. So what we are kind of assuming here is that our salary is going to be our dependent variable and our experience is going to be our independent variable, because we're saying that salary depends on experience. So if we knew someone's experience, then we could try and predict their weekly salary. So the first thing we're going to do is we are going to produce the Pearson's correlation coefficient. So to do this, we click on Analyze. We go down to correlate and we choose bivariate. We then select the variables that we want to find correlations between. For this data set, we're just finding the correlation between years of experience and weekly salary. So we move them both across into the variables box and then we click OK. So we can see here our correlations output, and so in the off diagonal we get the correlation between the variables. The correlation is 0.652, and we can also see the p-value for our correlation, which is 0.000. So very, very small p-value, much less than 0.05. So we're saying that this is a significant correlation between these two variables. The next step that we're going to do is we are going to do a regression model. So the regression model is where we're going to be using the years of experience in order to have a model where we can predict our weekly salary. So we go back up to Analyze, we go down to Regression, we choose the top one, Linear. So our dependent variable is our weekly salary. It's the one that we're trying to predict. And our independent variable is our years of experience. It's the one that we're using to do our prediction. If we click on Statistics, and most of this is okay, but we also want to have a look at our confidence intervals. So we tick the confidence intervals box, we click on Continue, and then we click on OK. So our regression process gives us a number of boxes. From this model summary one, the value that we're interested in is our adjusted R squared. So 0.404 is telling me that 40% of the variation in the weekly salary is being predicted by years of experience. So that's okay. It does mean 60% is not being predicted by this variable. And in more advanced units, we would learn about how we could put additional variables in to try and increase this. We're not going to worry about this ANOVA box, but if we come down to our bottom box, the key pieces we want to look at are our p-value. And so the p-value, the very bottom one here for years of experience, is telling me that years of experience is a significant predictor of weekly salary because our p-value is less than 0.05. We then want to look at our regression slope, or our regression coefficient, which is the one in this first box, 28.055. So that's telling me that for each extra year of experience, on average, we're expecting the weekly salary to increase by about $28. And there's a confidence interval related to this figure of $28. So our confidence interval at the end here is 15.4 to about 40.7. So that's telling me that on average, for each additional year of experience, we're expecting weekly salary to actually increase by between $15 and $40. So 28 is our point estimate, but we think that the actual value is going to be somewhere in this interval of $15 to $40 for each additional year of experience.